Solving inequalities using addition and subtraction. Just like with equations, our goal when we're solving inequalities is to get the variable by itself on one side. So just like with equations, our goal was to solve for x or get x by itself or whatever our variable was. And just like with equations, our goal when we're solving inequalities is also going to get the variable on one side by itself. In order to isolate or get the variable on one side by itself, we use inverse operations. This all should be sounding very familiar to you right now. Remember, the inverse operations are the opposite of addition, or the inverse of addition is subtraction, and remember that these are the inverse of each other. So the opposite of addition is subtraction, and the opposite of subtraction is addition. And the opposite or inverse of multiplication is division. And again, just like with addition and subtraction, it goes both ways. So the inverse of division is multiplication. Now today we're just talking about addition and subtraction, but I wanted to review really quickly all of the inverse operations that we've talked about thus far. Let's try to solve an inequality. Notice that I have -7 plus q is less than -2. In order to get the variable on one side by itself, look at where q is and ask yourself, what are you doing to q? Well, on the same side as q, we have -7 plus q. So I need to get rid of the -7. To get rid of a -7, you do the opposite or add 7 to both sides. Remember, you can't just add 7 to one side, you have to add 7 to both sides. That's true for equations and it's going to be true for inequalities. When you look at the left side, you have -7 plus 7. Well, -7 plus 7 is 0, so they go away. So you're left with q is less than, and -2 plus 7 is 5. Remember your integer rules. You have a different sign, so you subtract the numbers to keep the sign of the larger number. Now, with inequalities yesterday, we talked about graphing them. Today, we're going to go ahead and graph these also. So when I solved for q, I have q is less than 5. To graph that on a number line, I need to have a number line, and 5 needs to be on the number line. I am going to have an open circle or an open dot at 5 because it's not or equal to, it's just less than. And then if q is less than 5, I need to shade to the left because the numbers to the left of 5 on my number line are less than 5. The next example, we have -3 is greater than or equal to u minus 1. Remember, just like with equations, we're asking ourselves what is happening to the variable. If you look at the variable u is being subtracted by 1. So I need to do the opposite of subtracting 1, which is adding 1. So if I add 1 to one side of the inequality, I have to add 1 to the other side of the inequality sign also. On the right side, -1 plus 1 cancel out, so you're just left with u. And on the left side, you have -3 plus 1. Well, a -3 plus 1, you have different signs again, so you have to subtract the numbers, keep the sign of the bigger number, and you get -2 is greater than or equal to u. If you remember from yesterday, we don't necessarily like to try to graph an inequality when my variable is on the right side. I generally want the variable on my left side because it's easier to understand the relationship between the two. It's no problem, I can get the variable on the left side, but in order to do that, I have to flip everything around. So I'm going to flip and I'm going to make u first and the -2 be on the right side of the inequality sign, but when I do that, I also have to flip the inequality sign. So instead of having -2 is greater than or equal to u, now I'm going to have u is less than or equal to -2. Both of these statements are saying the exact same thing. Notice in the first inequality, the inequality sign is open towards -2. And in the second inequality that I just wrote, the inequality sign is still open towards 2. So both of them are saying the same thing. It's just written in the reverse order, which is totally fine. Now, when I have u is less than or equal to -2, I'm ready to graph it on a number line. So I have my number line. I need a closed circle at 2. And I need to shade to the left in this situation because the numbers to the left of -2 are less than -2. The next example says x plus 6 is less than -8. I need to get rid of adding 6. The way that I get rid of adding 6 is by subtracting 6 from both sides of the inequality sign. 6 minus 6 is going to cancel each other out. They're going to go away. So I'm left with x is less than, you have -8 minus 6. When you have -8 minus 6, you have the same signs. Remember, when you have the same signs, you're going to add the numbers and keep the sign. So 8 plus 6 is 14, and we're going to keep it a -14. Notice I've brought everything else down exactly how it was before. That's very important. When you are adding or subtracting from the same thing from both sides of an inequality, you need to make sure that you're very careful and you write the inequality sign just the same as it is in your original problem. Notice I said with adding and subtracting. Tomorrow we'll talk about multiplying and dividing, and there is going to be a special case where you do flip the sign, but we have not talked about that yet. So when adding and subtracting, keep the sign the same. Just be careful when you're rewriting it down in your problem. I have x is less than -14. My variable is already on the left side, so I'm ready to go ahead and graph. Obviously, on my graph, I need a -14 on my number line. To graph x is less than -14, I need an open circle at -14, and I need to shade to the left because the numbers to the left of -14 are less than -14. The next example says 10 is greater than b plus 16. Always ask yourself, what are you doing to the variable? In this case, I am adding 16 to b. So I need to do the opposite of that, which would mean I need to subtract 16 from both sides. My 16s cancel out on the right side, so I'm just left with b on the right side. And on the left, I have 10 minus 16. Notice I have a positive 10 minus 16, which means that I have different signs. Subtract the numbers, keep the sign of the bigger number, and you have a -6 is greater than b. I'm not crazy about trying to graph an inequality when my variable is on the right side, so I do need to go ahead and try to get b on the left side of this inequality. I can do that by flipping everything over. So I'm going to have b is less than -6. Now if I know that b is less than -6, it's easier for me to graph. I need to have a number line with -6 on it. I need an open circle at -6, and I need to shade to the left because b is less than -6. The numbers to the left of -6 are less than -6. The next example says 18 is subtracted from a number. The result is at least 5. What numbers are solutions? Take that first statement. It says 18 is subtracted from a number, which means we're going to start with a number, and then 18 is going to be subtracted from that. So I can write that sentence as x minus 18. Now you could have used a different variable, that would be fine. Go back to your original problem. 18 is subtracted from a number, we have that. The result is at least 5, which means that x minus 18 has to be at least 5. If you think back to yesterday's lesson, at least, you need to be thinking x minus 18 has to be greater than or equal to 5 to be at least 5. That means 5 is the lowest it can be, or it could be higher than that. Then it asks me what numbers are solutions. In order to find what numbers are solutions, I need to solve for x, which means I need to get rid of the subtracting 18 by adding 18 to both sides. When you add 18 to both sides, your 18s cancel out and you're left with x is greater than 23. The next example says the auditorium holds at most 300 people. There are 89 students who bought tickets to one night of the school play. How many adults can attend that night's performance? If an auditorium holds 300 people, that means that is the maximum that can be in the auditorium. So you can have 300 people or you could have fewer, but you are not going to be able to have more than 300. Notice that 89 tickets have already been bought by students, so we know that 89 students are going. We do not know the number of adults going, so that's going to be our variable. To find how many people are there all together, I would need to add adults plus students. Adults is unknown, so adults could be my x, plus we know that 89 students have already bought tickets. 89 students are attending. We know that x, the number of adults, plus 89, the number of students, has to be less than or equal to 300 because the maximum number of people that can be in the auditorium is 300. To solve for x, I need to subtract 89 from both sides, and when I subtract 89 from both sides, I get x is less than or equal to 211, which means that 211 people can come or fewer, but there cannot be more. So 212 people couldn't come. One person would have to be turned away because there's not a seat for them to watch the play. These next two examples, we're trying to write inequalities from a scale. Notice I have a scale, and this is more of like a balance. If what is on both sides of this scale were equal, we would have a straight across line or horizontal line across. Because we have on the right side that is down and on the left side has risen, we know if you think about a scale what happens, the more you have on one side or the heavier one side is, the more it goes down. So we know that on a scale, the side that is down has to be greater than the side that is up, or it's going to weigh more, there's going to be more on it. So I can automatically say that the inequality that I need to use would be the less than symbol. It needs to be open towards the side with all of the circles on it because that side is down, which means it is greater. Now, notice that each circle has a 1 in it, so I just need to count the number of circles on the right side. When I do that, I find that there are 14 on the right, and if you look on the left side of the scale, you have 2 circles, so you have 2, and you have an x. So we can write 2 and an x as 2 plus x or x plus 2. It doesn't matter which way you write it. Now, if you combine all of these to write the inequality, x plus 2 is less than 14. I need to solve this inequality. To solve the inequality, I would subtract 2 from both sides. When you subtract 2 from both sides, you find that x is less than 12. This next example, we again have a scale. This time, the side on the left has been pushed down. Remember, when a scale, whichever side is down, that is the side that is greater. So my inequality needs to be open towards the left side because that side of the scale has been pushed down. There is more weight on that side than there is on the right side. So the inequality sign that I'm going to use is greater than. On the right side, notice that I have an x and then I have 5 ones. So x plus 5 on the right. And on the left side, I have 6 ones, so it's just 6. Now I need to solve for x. To get x by itself, I need to do the opposite of adding 5, which is subtracting 5 from both sides. When you subtract 5 from both sides, you find that 1 is greater than x. Today's assignment is on page 189. It's numbers 2 through 18 even and 27 through 29.